The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thank you for joining us today. A quick few house rules before we get started. This session is going to be recorded and the slides are going to be made available. You will be getting a follow-up email to links of both of these, so not to worry. If you have any questions, there's a question box that you can submit them to. We're going to be doing a Q&A at the end of the webinar to answer everything. So without any other hold up, here is our presentation on operations by pull request and Ansible GitOps story by Tim Apnell.
All right, thank you, Elle. Hello, everyone. As Elle said, I'm Tim Apnell. I'm a product manager and evangelist on the Ansible team at Red Hat. I've been involved with the Ansible project since the beginning days as a contributor, user, an Ansible consultant, and now I'm a product manager. So I've been around Ansible and automation a lot, and I've seen it from all the different angles. In the past couple of years, I've been looking at how Ansible could be useful when applied to automating cloud native systems, and more specifically to Kubernetes. When I first heard about GitOps, I was really intrigued by the possibilities, being a former developer and consultant and a longtime advocate of DevOps practices. And more recently, when we came out with the automation webhooks in Ansible Tower, which will be a important part of this talk, it occurred to me that Ansible could facilitate GitOps workflows and that it provided some unique benefits to the practice. So that led me to create an option, a POC to go ahead and see if this idea I had is something that would work, and if this is something that you could indeed use Ansible for. So this leads to this presentation here, what I'll be covering, which is, we're going to explain what is GitOps, what do we mean by GitOps, what's the traditional or the more conventional accepted GitOps definition out there. We'll see that it's one that is a little sometimes vague, and there are different flavors of it, but try to hone down to at least a general idea of what it is. And then talk some about using Ansible and its advantages, and show how this GitOps done the Ansible way would look like through both some diagrams and walkthrough and then a demo. Okay. Typically, when I give this talk, or when I could give this talk in person, I would ask what everyone was, how familiar they were with Kubernetes and with operators and with Ansible Tower and GitOps. I'm going to make some assumptions here that we're all somewhat familiar with Ansible since we are on an Ansible webinar, and have a little bit of familiarity with Kubernetes and operators. But we'll go, since this is a talk is about GitOps, we'll go a little deeper into that particular topic. So moving on, what is GitOps? Well, like so many terms that evolve and emerged from the insights and practices that came before it, finding a definitive meaning of the term GitOps, I found, can be a bit elusive. The term GitOps was originally coined by Alexis Richardson. He's the CEO and founder of a company called Weaveworks. And so a lot of how I'm going to define GitOps here comes directly from Alexis and Weaveworks. Here on my screen, I have the initial blog post that explains the concepts that put some of the GitOps baseline ideas out there. It doesn't provide a concise definition. If you go back and read this blog post, and I recommend you do, if you want to learn more about GitOps. So depending on who you ask, you'll get varying definitions of the term GitOps. Really, GitOps is the ideas that are in GitOps started with Martin Fowler's comprehensive continuous integration overview that he did in 2006, and it descends from the ideas of site reliability engineering, from DevOps culture, and infrastructure as code patterns. GitOps, though, is a much more prescriptive style of doing infrastructure as code based on the experience and wisdom of what's worked in deploying and managing large, sophisticated, distributed, and more specifically, cloud-native systems out there. So after doing a lot of reading and trying to come to some sort of definition of GitOps, I came upon this one that came from Weaveworks that I thought really concisely defines and captured the essence of many ways that GitOps has been explained. First is, and I've gone ahead and bolded the key words to this definition. First is that it's a declarative desired state that you can define your infrastructure in this declarative way, that you have a single source of truth, and that Git is the UI, if you will, of this workflow, of this system. Often you'll read things like immutable architectures, and even more specifically, Kubernetes cluster management as attributes of GitOps. But that's something that I propose is a bit too prescriptive and limiting. I believe you should take full advantage of immutability in Kubernetes if you can. They certainly make a GitOps workflow easier to implement effectively. But from this point on in the talk, I'm going to treat them as suggestions and preferences, not as requirements of GitOps. Okay, so elaborating on that core GitOps definition, here are some of the principles of the GitOps workflow. The entire system is described declaratively, and what we mean by that is that the configuration is guaranteed by a set of facts instead of a set of instructions. So, for example, in a declarative system, you would say there are 10 Redis servers, rather than say start 10 Redis servers and tell me if it worked or not. Another part is that the declarative state is versioned in Git. So with declarative tools, your entire set of configuration files can be version controlled just like your code. By using Git as your single source of truth, you can more easily deploy and roll back to different states of your system. And more importantly, when disaster strikes, your cluster's infrastructure can be dependably and quickly set back up again, reproduced. Another key part is that you get all the goodness and the workflows that you as developers are used to, I should say. You all might not be developers, but what you get out of Git with your code can be applied to your infrastructure. You can do code reviews, you can do audits, you can use all the logging and see what's going on there, who made what changes when, those sorts of things. And then another part is that there are software agents to ensure the correctness and alert on divergence of your desired state from the reality of your system. Here I'm going to interpret agent liberally and define it as a software mechanism that facilitates this converging of desired state and what's been provisioned in your infrastructure and applications, and we'll see why. It'll be an ongoing theme as I continue here. Okay, so this diagram here is what is a typical GitOps workflow looks like from a conceptual level. Automating a delivery pipeline to roll out changes to your infrastructure when changes are made to Git. The engineers develop their software using the standard workflow and continuous integration practices as they usually do. When a release is ready, it gets pushed to a registry. So then to roll out the new release, a change is made in Git that declares that the cluster should use the new release. At that point, the GitOps controller agent, if you will, that's running on the cluster picks up a commit that commit, that change in state that happened in the Git repository, and then pulls that in to the system. Like I said, typically these Git controllers are some type of Kubernetes operator. A good example of that is Flux from Weaveworks. We've already talked about them. At that point, you have the operator. The operator begins working to align the current state of the cluster with the desired state that it is pulled from the Git repository. So a couple things of note here that that I want to highlight. The one is that in GitOps, it's highly recommended that you keep your continuous integration system separate from the continuous delivery mechanism. This is just considered a best practice because you don't want to be able to have one system that can go from writing code and pushing something into production. So it's a good idea to have that sort of separation to keep your system both secure and also to not accidentally push changes that you're not ready to push while in development. And the other is that the GitOps is giving you, it allows you to choose more of the tools that you are accustomed to working with, because it's not one single tool can do everything, and it just gives you a lot more flexibility to work with in getting done what you need to do. All right. So the purpose of this presentation is not to sell you on the merits of GitOps, but to show you how you can use Ansible and once you've bought into the idea of GitOps, and how GitOps can provide the flexibility and the capabilities to apply this type of workflow to your environments. So quickly going over these, the idea is one of the top things is you get is increased productivity. The continuous deployment automation with an integrated feedback loop speeds up your mean time to deployment. We hear many organizations that have begun using GitOps, getting like 30 to 100 times more changes done per day, the ability to increase the overall deployment output 2 to 3 times that they're used to. The other is that you have an enhanced developer experience. You can push code and not containers. That developers are using the tools that they're already very familiar with, very comfortable with, very proficient at, to manage these updates and features more rapidly. And it also gives them a nice abstraction layer from having to know the ins and outs of the system, because they're only focused on that declarative definition. You also get improved stability when you use a Git workflow to manage your clusters or whatever your system is. You can automatically gain all that convenient audit log and the cluster changes. You can see them from the outside and track what changed and roll back, things like that we've already talked about, and that leads into higher reliability. With those capabilities, the ability to roll back in your history or roll forward or to fork gives you a lot of stability and to be able to reproduce where you are at. I'm sorry, not last, but there's also a lot of consistency and standardization benefits from this, because GitOps provides a model for making your infrastructure, your apps, and whatever else you're working with in your system, and have that consistent end-to-end workflow across the entire organization. And then finally, you have stronger security guarantees. That Git has a real strong correctness and security guarantees that are backed by its strong cryptography and its ability to track and manage changes, as well as the ability to sign changes, prove authorship, origin, things like that. So these are all great benefits to working with a tool like Git and having your infrastructure as code in a GitOps workflow. Okay, So as I was saying when I started this presentation, when I first heard about GitOps, I was really intrigued by its possibilities. And you know, I was taking it all in, reading up on it as much as I could, looking at the tools that are out there. And that's why it occurred to me that like a light bulb went off that, oh, hey, this might be something that you could use Ansible for. I should try this out. So this is what led to my exploration and this POC that I'll demo at the end. So just to add a little bit of context, I know we're on an Ansible webinar and we're all familiar with Ansible, but I always like to come back to the core principles that Ansible is based on, because they do play into why you want to consider using Ansible for GitOps and why there are unique benefits to using Ansible. Ansible has been based on these principles of being simple, powerful, and agentless from the very beginning, and that it's also a desired state engine. That is what really set off that light bulb in my head, because that's a key part of making GitOps works, is the desired state engine there. And then it's also that the content is human readable. Many people can participate in it. You don't need special programming skills, so it's not the exclusive domain of developers and those who can code necessarily. You can get more junior members of your team involved. You can get operators, meaning sysadmins. I shouldn't use operators since we're also talking about Kubernetes operators in this talk, but sysadmins involved. You can just a lot more inclusivity into who can participate and contribute to what's happening there. So in this diagram here, we see what is commonly used when Ansible's in the mix. It's just like I said, it's a common pattern that we see for continuous delivery, and this was prior to the automation hooks feature coming out in Tower. In this case here, you have the changes would happen in the repository that then would get picked up by a CI tool, typically Jenkins, but there are others out there that are used. And that Jenkins then would call the Tower RESTful API to launch an automation job inside of Tower. This worked fine, and many of our users and customers use this. But it's not intuitive, and it also can be a little bit convoluted, and if you're not careful, things can break. There's also that risk I talked about of your CI system doing CD, because you now have the keys to production and things like that in this one system. So it can be an attack vector potentially or it can also just be mistakenly used to push something to production that you weren't ready to push at that point. So with the release of Ansible Tower 3.6 and the automate that we introduced something called automation webhooks that were made available to make it easier and more intuitive to do Git-centric workflows and do it in an Ansible native way. So these automation webhooks allow you to catch events from a source control system like GitHub, GitLab, actually GitHub Enterprise too, and use them to automatically trigger automation, update projects, update inventories, and perform deployments, all without having to go into Tower and directly, or directly call Tower or go into the UI. Or use some type of other tool such as Jenkins to trigger that job to run. So with these new capabilities with the automation webhooks, there's no need for that additional tool to monitor the repos and launch the automation jobs when those changes occur. That just by making a commit, Git issues an event to Ansible's automation webhooks and then triggers a job or a workflow to make this automation launch to run. So it's a lot more straightforward, a lot more direct, and a simplified workflow by taking out that middle piece. So here I have on the screen part of the interface of the job template options, and this is how you would set up a webhook by going in to your job templates. And if you look over on the right side, there's an option called Enable Webhooks. When you click that, this bottom half of the screen, I wish I had a pointer here, will be exposed to you and allow you to pick what type of webhook service you're using, and then it will give you a webhook URL. At that point, you can go to your Git system and get a personal access token. That then you can bring back and put in the webhook key here that allows you to have this credential set up that will allow you to have your Git system call Tower and run it securely and run that particular job for you. So that each of those URLs that the system generates for you is unique, so that it knows specifically which job it is that you want to run when a particular event happens on a particular repo. So we've now reviewed how you can create Git-centric infrastructure as code deployment workflows with these new capabilities. So what I've shown so far is, like I said, it's giving you the foundation, but GitOps is more of a prescriptive workflow and a particular form of infrastructure as code, though. So doing GitOps looks something more like what I have on this diagram here. Here we have, from the one that we saw earlier, that was the more traditional GitOps workflow and diagram. Here, Ansible Tower is replacing the GitOps agent operator that runs on a given cluster and pulls in the state of your configuration, which is like I said, an example of this is Flux from Weaveworks. But here, Ansible Tower works with, in this case, with operators running on a Kubernetes cluster or directly with the Kubernetes API and its resources that are built in. You can use application operators in kind of a push-pull sort of approach, which is what I'll show in my demo, the POC that I had created when I was studying this. So the idea is that the Tower pushes the configuration to the cluster, and that you have, well, sorry, I glossed over something there. If I could back up. Here you can use an operator, but the operators that you're working with are application specific rather than ones that are just doing the GitOps operations for you. So it's providing a lot more flexibility to apply your GitOps workflow and taking it beyond Kubernetes at this point to things like public-private cloud services, networking infrastructure, all this because you don't have to use and run everything through an operator that will only run on a Kubernetes cluster. So there are rules you use in your GitOps pipelines. Ansible provides some advantages that make for these type of work. Yes.
You're breaking up a little bit. Just wanted to let you know that we're having a little bit of audio issues.
Okay. I'm wondering if my home connection.
So you're sounding better now, but you were breaking up a little bit before.
Okay. All right. Sorry, I'm just checking what my home Wi-Fi here is doing. All right. Well, let's cross our fingers. Let me know if I start breaking up again, and I'll see what I can do here.
Okay. Yeah, you sound good now.
Okay. Great. Excellent. All right. Where is it? Yes. Advantages of using Ansible. So there are many tools you can use in your GitOps pipeline, but Ansible is providing some unique advantages that we think make it ideal for these type of workflows, and that give you the power to take these principles of GitOps and this type of way of working and take it beyond Kubernetes. So as I've already mentioned, that Ansible is a desired state engine that enables this type of declarative modeling of systems without the scripting through roles and playbooks. And it's there's a lot of Ansible experience out there. I'm sure I'm talking to a lot of it right now. So you have that same tried and trusted Ansible tooling that's been developed over years, and it has a tremendous knowledge base out there in the industry. So it allows teams to transition to doing GitOps without having to learn new skills in order to do that. What's more important to note, though, is that it also provides the flexibility to apply GitOps workflow principles to systems other than Kubernetes. This is a key unique benefit to using Ansible in a GitOps workflow. So now you can apply GitOps to public-private cloud services. You can apply GitOps to network infrastructure and other things outside of the cloud-native realm, because you're not required to work through an operator running on a Kubernetes cluster. You can use the K8s modules and many others that are included with Ansible, that are part of Ansible, and you can use that to manage the applications in Kubernetes or existing traditional IT infrastructure, or across both with one simple language and one control plane, one system. You also have the flexibility and the freedom to use the tools for your needs and to tailor your pipelines to how you work or how your organization works or where your organization has made its investments. So just remember, a strength of Ansible is that it really excels as IT automation glue. And that's another key benefit here, is to bringing in those type of things into your GitOps workflow and what you can do. Okay, so at this point I've talked, I think, enough about GitOps, and hopefully I've shown you, or we've discussed the benefits of Ansible in a GitOps workflow. Now I'm going to show you how that all comes together in a demo. So before I go actually run the demo itself, fingers crossed, I just wanted to talk a little bit about what it is I'm going to show here so you can take it in, because a lot's happening in the background across multiple systems here. In this case, we're going to be showing that Ansible's working as the GitOps operator, agent, controller, and that it's running outside of the Kubernetes cluster. And again, I'm using, when I say agent, I'm using this loosely. It's manager, controller. Also, with it being independent, we can support, being independent of a specific cluster, we can actually support going out to many clusters, multiple clusters, and other environments. Like I said, as I've keep repeating, I know, but it is cloud and network infrastructure. Also in this demo, Ansible Tower is coordinating with an operator. Like I said, it was, when I did this POC, I used what I had available to me, and I was working a lot on developing operators with Ansible, which is a whole other talk I give. So that's what I had readily available. At some point, I have to, not being a network guy, I have to build a demo where we work with networking infrastructure or do something working with a public cloud system that isn't Kubernetes based. But that's for another day and another webinar you'll have to tune into. So just the key point I want to make here is that the operator I'm using is not a dedicated GitOps operator like Flux. You don't have to work with an operator, though. We recommend operators. We really believe in operators, but it's not a requirement, where in other systems out there or other implementations of GitOps, you'll see where it's actually required. Okay. So in this POC, we have two components that I just wanted to, like I said, laying this out. This is going to be the system, the service I'm deploying is a dynamic scalable caching service. There are two components to it. Memcache, which has been around a very long time and has been used extensively by many. It's a simple key value store for doing distributed memory caching, speeding up database calls, API calls, page renders, things like that. But memcaches are single nodes. They're not really very sophisticated at all. So Facebook created another a project called McRouter, and that is a memcache protocol router that sits in front of a pool of these simple memcache nodes and can do all type of advanced functionality that allows you to scale memcache deployments and do things like replication and failover and all type of other schemes. You don't have to know much about it other than just to give you an idea of what I'm trying to show you here. So the idea here is that we've developed an operator using Ansible that will deploy the McRouter pod that sits in front of your memcache node, and it like you have a pool of these memcache nodes that are there. So the operator needs to know what nodes are in its pool, so as you scale down or something happens that you need to scale up, the operator can tell McRouter what's happening inside of its pool and make adjustments for it automatically. So something to keep in mind, that this is where operators, I know this isn't a talk about operators, but where they become useful, because this is all happening on the cluster through a single API call, and it's happening without human intervention. So that's a whole other value proposition on its own. So with that, let me move on to the demo. Enough about operators. That's another one of my passion projects here. I'm going to, let's see, go over to my terminal. Let's see, hopefully everyone can see that. Yes, okay, great. All right, so what I did ahead of time was I have a Kubernetes cluster running out in the cloud here. I've already installed the operator ahead of time, but it's not managing anything, and I don't have anything deployed to my Kubernetes cluster at this time. What I have here is I'm already sitting in a project that I've created that has the configuration files for this service. It also has the logic for deploying the service and managing it. I did that at convenience. Depending how you work, you may put everything into roles and then pull the roles in. There's a lot of different ways that you can organize your project. It's not doing GitOps with Ansible isn't dependent on how you lay out your project here. So let me show you some of the things that I'm working with. Whoop. Wrong file. Okay. So this is my playbook very quickly. The first task is pulling in the configuration in this case. The second thing is a bit of a hack I had to do, and I'll talk about this after I finish the demo. We'll come back to that. And then it's defining the cache service resource, the CR that talks to the operator itself. Let's see. This is the template that third task pulls in that allows me to dynamically create that McRouter resource, which is the name of the operator in this case. And then most importantly, this is the config for my test here. So this is the one that we're going to be working in. So this is pretty simple. I only have a few different parameters here, but it's one that, like I said, I'm just trying to get across the principles of GitOps. So let's go and change this configuration. I'm going to say I'm only going to need 3 nodes, 3 memcache nodes in my pool here. I'm going to keep it using a replicated scenario in the default namespace, and I'm going to call it Tema Test. In fact, you know what? Maybe Yeah, we'll stick with team attest here. So, okay. So I've made my configuration changes. I'm working today, and they say, hey, you need to scale down the caching service. We're using too many nodes. So great, made a change. Let's I'm going to commit that now. So now I made the commit. It's there. Nothing's going to happen yet, though, because let's see, it goes whoop, because I haven't pushed it yet. So what I have here, over here, I have Tower running. I've already pre-configured what job I'm going to run, or the job I want to run when this commit happens. So let me go over to that here. So it's going to be this one here. So we've set this up. We see here I've done the enabled webhook as I showed in my screenshot, and all this is configured. And it's going to pull in the playbook that I had showed you, the very simple playbook. I've also set up the credentials in order to let Git and Tower talk to each other. So let me go back to the jobs here where you can see that when it runs. So at this point, I'm going to go now push my changes. So it went through code review. Everyone's happy with the changes, or one or two people looked at it and said, yeah, that's what we want to do. So at this point, it gets merged, and then I'm going to go back. This will take a second. Oh, I should have. Yes. All right, we see here now the jobs are kicking off inside of it here. We have it did a project update, and now it's running. Should only take a second because this is a very simple playbook. And if we go back, we see here now where we have it's now rolled out my caching service, and it's given it a pool of 3 memcache nodes. And that was with one single Kubernetes resource change, one single API call from there. So let's take a look at what we have in that job. We can see here it ran the local changes, all the stuff you're used to with using Ansible Tower, but this was all fired by the webhook and by me making that commit. So let's make a change. Let's say things are heating up, things are looking good, and you were running out of capacity, that we're starting to get a lot of misses in our cache because of we don't have enough capacity, and we're using up what we have, and we want to go to 5. So I'm going to save that. Make another change. Okay. Oop. Okay, that commit went through. If we go back to jobs, there we see now it's running the my playbook again, my job. Looks like it ran. Everything's green. And now we see we have 5, and with it now rolled out 2 more for me automatically. And just to go back to plug operators a little bit more, that one that you see up there with the kind of intelligible name, the second pod listed, that's the operator itself, and that operator has been updated so that it knows that it now has 5 nodes to work with in its pool. Okay, so that's the basic proof of concept of using Ansible in a GitOps workflow here. There's should go back to my slides here. Okay. There's more that you can do than just what I've showed you. I showed you a job template. You can very easily apply this to workflow. So you can have automation webhooks on a workflow so that you string together a whole series of and a whole logic chain of different jobs and workflows here So that's another way that you can take this further and get more flexibility and more power out of your GitOps pipeline that you create. You can also take advantage of other features that are inside of Tower, such as sending notifications as different jobs run and things of that nature, and all the logging that Tower does. You just get you also have the flexibility that if you have reasons to not strictly follow GitOps, you can do GitOps-ish workflows, I'll call it. For example, Ansible implemented approval steps in a recent release. And if you worked in a highly regulated area, maybe there needs to be some type of approval step in the middle of the workflow. It's very much GitOps, but there's this approval step. You have the flexibility to do that when you're working with Ansible in this case. So as I mentioned, in doing the POC, I found that there was some room for improvement. The good part about being a product manager is that I could feed that back to my colleagues, and we've already begun working on improving some of the things to make this a better experience. One of the first ones I ran into, and this goes back to that one task that I said was a bit of a hack in my playbook, is that the Ansible Tower didn't support Kubernetes credential and secrets at the time. You couldn't take what would normally be in your kube control configuration for connecting to the Kubernetes API and have it as a credential inside of Tower. So that was a problem. We've already, our engineers have already implemented and merged it. That'll be coming out in the next version of Tower that will be built in. Another thing is that when I was setting up my Tower system, I didn't have native support of these Kubernetes modules. I had to install them. So get the modules in, get all the different Python libraries in there. That's something that we're looking to change, that all those things will be included in Tower itself so that you don't have to go through that yourself when you install the Ansible platform and apply it to your GitOps workflows. I found some rough edges in different parts of the K8s module. For example, that there wasn't native vault support of reading a file that had been vaulted because of the first item. I had to vault my kube config file in order to keep it secure while it's sitting in a repo. We have that work in progress. I actually think the native vault support got merged just the other day. We also want to add some other things like template support, things of that nature. So number of things going on there that are in progress right now. And a couple other things worth noting and being fair and transparent is that Tower is a general automation system and has a general automation UI. It's not a specific one if you're working in Kubernetes or specifically looking for something that's very specifically GitOps, such as Argo CD. That's probably something we will not be able to address, but it's just something to consider. And then one other thing that, as I've given this talk before, some people have pointed out, is that job and workflow templates inside of Tower are stored in the database. They're not something that you could store in a Git repo. So it's one area where it breaks a little bit from infrastructure as code and then by extension GitOps that we could, we may want to look into. We're always thinking about these things. Yeah. So starting to wrap up here. If you're interested in learning more, reading up more on GitOps, these are some resources that I really recommend you check out and read up. These are some of the things that I read myself in learning this stuff a year or so ago. There's also some links to the Ansible K8s module, which is core to if you're working with Kubernetes. And yeah, some more thoughts on using Ansible with this type of stuff. And sorry, I lost my window there for a second. We also before I go, I wanted to mention that later in October, we'll be hosting Ansible Fest, our annual community and user festival. Ansible community will be talking about all things Ansible, Kubernetes, GitOps, continuous deployment, and a whole lot more. So this year is going to be virtual, and it is free for all who want to attend. So just go to ansible.com/AnsibleFest to register. It'll be happening October 13th and 14th. And with that, I can take some questions. Let's see what we have here. All right. So let me, I'm sorry if I'm just looking at the questions, that all these good questions that have been asked while I was presenting. So is design consideration in setting up Ansible in pull configurations? I'm not sure, not clear on what that, I mean, you have to have considerations in that you have to have a system that is can be represented declaratively. You can do some imperative type of things inside of Ansible. So you wouldn't want to do those things in a GitOps workflow. Those things happen outside of that. You will need to consider creating things that you that tend towards being immutable, or can also be very flexible. A lot of the principles of site reliability engineering and microservice architecture have to be considered here. It'd be really hard to take a very like legacy monolithic type of system and apply GitOps to it, because of the way everything is just kind of glued together. But that's more of a general thing than just being limited to GitOps. Let me see here. When will Tower support Bitbucket webhooks? That is an excellent question. We are trying. We are looking to add that. It's just been a matter of working with Atlassian and getting the right demo or setup for our engineers to work with, and getting it into the work queue. We're doing a lot of great things in a lot of different areas, and it's just one of the things we haven't gotten around to. So my recommendation is to just continue voicing that requirement, and we will, you know, with both us and your reps at Atlassian, and we'll work on that. We definitely want to get to that. We just haven't had a chance to do that at this point. Boy. So I guess my audio was breaking up a lot based on all these questions, which are all right. I'm still here. I'm sorry. There's a lot. I got asked a lot of questions about my audio that I'm having to sort through here. Are there any plans to add a webhook service for Azure DevOps to Tower? I'm not sure I've seen that actual feature request. I'm not on the Tower team directly, but we're very good partners with the Azure team at Microsoft, and I'm sure that type of thing is being discussed. I will make a note of that one and pass it on. At this time, it is not slated for the next release of Tower, which will come out later this year. I cannot comment on whether it would come in a later one. I would, and it's my personal thing, I would wager it will, but it's something that we'll definitely keep in mind. So thanks for the recommendation or the suggestion. Yes, the last resource slide. Will I go back to it? Let's do that while I'm continuing to talk. There you go. And okay, so here's a question. My Memcache playbook did manual scaling. Can this be automated up and down scaling instead of needing to commit and push a run of a job? The answer is yes. That is just the way that I implemented it. This is where a Kubernetes operator could come into play and is part of the idea and the scope of what you use an operator for, where it could watch your logs or whatever it is that's out there, and if it sees a certain threshold get crossed, take an action. So this is something that I could have done, and it would have, in the case of what I showed, it would have been in the operator itself. I suppose if you were working in cloud, you could be doing something in CloudWatch, but then again, Amazon has functions to allow you to scale up EC2 instances and things there. So yeah, I could have done it that way. It just wasn't the way that I implemented it. Do webhooks exist for firewall configuration and STIG policies? It absolutely could. It's all a matter of what do you have in a playbook, and hooking up a webhook and a Git repository with that those declarative configurations. So it's declared information of the declared state of your firewall that goes into a repo that then would cause an event to fire that would cause Ansible to run and make changes to your firewall. So this is what I was talking about, having the flexibility to go beyond Kubernetes. That's a great example there, Don. So yeah, so firewall configuration, STIG policies, absolutely. And the same goes for AWS. And I suppose you could do satellite the same way. So really, any system that you can put into a declarative state where you're defining what state you want it to be in, you should be able to apply GitOps to. It's just a matter then of writing the Ansible playbook or applying the Ansible roles in order to take that definition and get your systems into that state for real, or the actual state of the system. Okay, so we got a clarification on that pull configuration. I mean, typically Ansible's geared towards doing push architecture, but if you did really want to use agents and you did really want to do a pull, you could do something along those lines. It's not the most. It's just not the way that Ansible is geared. You know, a key tenant philosophy has been to be agentless, and that means a push architecture. It doesn't mean that you can't do things. Certainly, with Kubernetes operators, those are a sort of agent-like mechanism. You could pull things across there, but when it would be outside of Kubernetes and cloud native, you'd have to find other mechanisms for doing the pull. Let's see here. I'm still looking through questions. I still have a couple more minutes. So when we use webhooks, any option to set up approval by someone to run the play only when he approves. Yes, so a recent release of Tower, I believe it's 3.7, did bring along an approval step in it. So you could attach that to a given job template that would initially get triggered by, I believe you can do this, I haven't actually tried it, but it would get triggered by the Git event, start to run, and then ask for the approval. Someone then would approve it, and then it would continue running at that point. And that's when I talked about a GitOps workflow, that you have that flexibility when you're working with Ansible. Those are the type of scenarios that I meant. Let's see here. GCP is supported. Is it possible to place a webhook with 3 scale? I'm not familiar enough with 3 scale to know exactly what you are referring to there. If right now we support specific webhook format from GitHub and GitLab, and we're definitely looking at Bitbucket, and I'm sure over time we'll add others like Azure DevOps, which has come up. If they have something like that, we could use that theoretically in there. There's also other mechanisms inside of Tower that might be more applicable, and there's also the Tower RESTful API that could be utilized. So there's nothing out of the box right now today that's supported, but if you have a specific feature request and use case, it suggests either giving it to your Red Hat rep to funnel through to us, or posting under the AWX project on GitHub, and go from there. Okay, so right now I am now out of questions, Elle. So I guess we can wrap up here.
Yes, so thank you everyone for joining. I just want to reiterate that this webinar was recorded, and we are going to be sharing the recording and the slides with you in a follow-up email. So thank you everyone again for hopping on and listening with us, and you should be expecting an email here soon. So thank you, and thank you, Tim.
Yeah, thank you everyone. Thanks for listening.